Okay, homework. Okay, hopefully you copied this down. I already gave you it. Hopefully you saved them. Okay. And again, if you just wanna pause, if you just wanna do it by yourself and see how you do, and then just check with mine, I'll still work them out just in case you're confused on any of them. Okay, so we start with number. Oh my gosh, I totally gave you the wrong homework. No, I didn't. I gave you the right homework. Okay. Never mind. I gave you the right homework. I was looking at the wrong stuff. My bad. Okay. So number 9. Okay. It's saying the graph of a relation is shown in exercises 9 through 12. Part A is saying, is the relation a function? Okay. Now, remember I told you a function is a graph that does not have the same x values, like saying like 2 is used twice. So number 9, like let's say you had to draw like a horizontal line for 1. So the graph looks like this. Here's 1. So all these points right here have this point of 1, x of 1. So the answer is, it's asking if this is a function. It's no, okay? So if x has more than 1 point, then it's not a function. Okay. Well, and then part B, so A is no. Okay. So part B says, does the relation have an inverse, or does the relation have an inverse that is a function? Okay. Now, you might think, okay, what the heck? Like, how am I supposed to figure that out? I found a really simple way how to do it. So this is the x and y axis. So the inverse, you just basically rotate the graph over. So now this becomes the x-axis and this becomes the y-axis. So, and you just kind of do the same thing. Hopefully you can see this. So this becomes the x-axis, this becomes the y-axis. So, like let's say we did the same. Let's say we did 0.1 from the inverse. Okay. So here's 0.1. Here's x equals 1. So okay. So this x only has 1 point touching the x value. So now it's saying, is the inverse of this function does the relation have an inverse that is a function? So since this one has just 1 point touching all x values, then yes, it is a function. Okay? So B is yes. Okay? The same thing with the rest of them. 10A is yes, B is no, 11, A is yes, So this is what you should get for all of them. Okay, it's just the same. Keep the same thing. You just look at the book. So and then x and y, you just flip it. So now this is the x-axis, this is the y-axis. Okay, hopefully that makes sense. It makes sense to me. Anywho, I'll keep going. Other thing is, not related to math, hopefully you're staying focused on your research project. It is basically killing me right now. I absolutely hate it. Okay. Okay. Now, 13, it says, find the formula of f of negative 1x. Give the domain of f of negative 1, including any restrictions inherited from f. Okay, so what it's saying is, so we're doing number 13, so you have f of x equals 3x, 3x minus 6, okay? Basically it's saying find the inverse of this function like we just did before, so y equals 3x minus 6, you change the x and the y, so x equals 3y minus 6, plus 6 plus 6, x plus 6 equals 3y divided by 3, y equals, you can just leave it x plus 6 over 3, or you can do just, I did 1/3 x plus 2. It's the same thing, okay? So this and this, those are the same thing, okay? So now it's asking for the domain of this inverse. So when you look at this, if you get this one, you know that this looks like a reciprocal function, but it's not, because it doesn't have an x on the bottom, okay? If you do it like this, it's a little easier to see the domain, okay? So for this, it's just a identity function and stuff like that. So it's asking for the domain, okay? So the only domains that have restrictions are reciprocal functions and squaring functions, and then there's some exceptions, but I haven't come across one yet. Okay, so domain. If you do it this way, it's it's saying the denominator can't be 0 if there's an x on the bottom. But for this one, there's no x, so your domain is just all real numbers. It's easier to see for this one that it's all real numbers because it's not a reciprocal, okay? Hopefully that makes sense. Yeah. Okay. Number 15. Okay. F of x equals 2x minus 3x plus 1. Find the inverse. Oh, this one's probably a little harder. So y equals 2. But you can handle this problem. Okay, so I know this is kind of hard to see, so the x is right there. So you multiply the denominator, so you have x, y plus 1 equals 2y minus 3. Distribute this out. Let's see, wait, yeah. 2y plus x equals 2y minus 3. Okay? Subtract the x. xy minus 2y equals negative 3 minus x. Now, what you do with this is you have same. It's kind of like factoring it out because you have two variables that are same. You have y's. You both have y's. So you can take out the y. So leave the y out. Now you have x minus 2 equals negative 3 minus x. Okay? Now, easy. Now you just divide by x minus 2. X minus 2. I don't know. Hopefully you can see that. Okay? So, your final answer would be y equals negative 3 minus x over x minus 2. Okay? This is what your inverse would be. Okay? Hopefully you understand that. Okay, now it's asking for domain. Now, this is a reciprocal function because it has an x in the denominator. Okay, so remember, denominators cannot equal to 0 because then it's not a function. So you say x, this is kind of like what we did last chapter, so x cannot equal 2 because 2 minus 2 equals 0. So your domain is just x cannot equal 2. Alright? I just already started it, so you just square it, so you have x squared equals y minus 3. Okay, so you get this. You should know squaring functions are always all real numbers, so your domain just all real numbers, okay? $19. Sweet. Okay. Alright, 19. Yeah. Yeah, what I told you is right, how, and that, like, your new domain is, like, the ones we've been figuring out, but it's actually, like, let me check. I might shoot myself. Interesting. Okay. Number 17 isn't right in the back of the book. But, okay, Actually, what I've told you before, it's right. I'm sorry, I might have freaked you out just a tad. Okay, number 19. So, you have f of x equals x cubed, okay? So, pretty easy. Y equals x cubed. Okay, now switching it. Y cubed. Okay, so you have this. Now, you square root it, but you like cube, I don't know, it's cube root it? I'm not even sure if that's a real thing. So you have 3x, hopefully you can see that. It's like, you know, like the little 3 inside the root. Okay, now, I know I told you square root functions have restrictions on domains, okay? But cube root functions do not, okay? And I asked Mr. Thompson this, and he says roots that have odd numbers always have odd numbers with roots, always have all real numbers, but with even numbers, then it has restrictions, okay? So for your domain for this, it is all real numbers, okay? Yeah. Okay? Okay. 21. Okay. Okay. First thing you do is you cube root the size to get rid of the root. So x cubed equals, gosh darn it, I'm sorry. Y plus 5, okay? So this is what you should have now. Subtract the 5, pretty simple. Y equals x cubed minus 5, okay? All same thing with cubing functions. If you like remember on like the basic functions little packet we had, cubing functions are, their domain is all real numbers, so your domain for this is all real numbers, okay? Hopefully that makes sense. I actually don't remember when you come back. You said 3 weeks, but then you said like what was it? 12? Is that what you said? No, not 12. I don't remember. I thought you said like the 14th or something like that, and you've only been in Australia for like 2 weeks, so I might have just misheard you, but whatever. Anyway, okay, now number 23. 23, determine whether the function is 1 to 1. Okay. Oh, okay. So 23 through 26, you just have to do the first part, determine whether the function is 1 to 1. Okay? And it's kind of the same thing we did through 9 through 12 is you just see if the x's have more than 1 points being used. So first one for number 23, it's yes, it's a function. For 24, yes, it's a function. 25, yes, it's a function. Wait, come on. Oh my gosh. Ugh, I'm really sorry. Okay. You have to, you have to check both. Like, you have to check if it's a function by looking at it, and then, like, also looking at its inverse, okay? Like we did 9 through 12. Okay, so it's basically, for number 23, okay, you have this. If you look at it like as this regular function, so here's the x and y axis. So here's 1. It's only touching this point once, only touching x points once. If you flipped it, made this x, made this y, it still works with the same thing, okay? It's still 1 to 1, it's still x is 1 to 1, okay? So 23 is a yes. You probably hate me because I keep messing up. 23 is a yes. 24 is a no. 25 is a yes. 26 is a no. Okay? Hopefully you get that. Just switch x and y axis to see the inverse from the graph. Pretty easy. And I'll elaborate on 1-to-1 because we actually had a definition. I didn't do that with the last notes, but I'll do that after the homework part. Okay, 27. Okay, this is like number 2 we did on this. Okay, so you just plug in, f into g and g into x. Okay, so let's see. You can just pause the video or just work on it while I work on it. See if we get the same thing. should get both of them are equal to x. This is really easy stuff. I'm not gonna go through 28 and 30. It's just basically the same thing. You just plug in f into the x of g and then g to the x of f. And if the only thing is if it doesn't equal x, then it's not its inverse, okay? But I'll just tell you that all of them work. 28 and 30 work. So 27 is a yes. So 28 and 30 are yeses. You will just have to show the work. I'm not going to do them. I think I've done enough practices with you. Okay. Definition of one-to-one. A one-to-one function. I'll say this slow. I'm not going to write this down, okay? I'll just explain it. Okay. Write down one-to-one function. Okay. A function f of x is considered one-to-one if and only if, and then there's going to be 3 bullet points, okay? Bullet point number 1 is no 2 points share the same x coordinate, and no 2 points share the same y coordinate. Bullet point number 2. The function passes the vertical and horizontal line test. Bullet point 3, the inverse f of negative 1x, so it would look f negative 1x, it would look like this, okay? The inverse of f of negative 1x is a function. Okay. That's it for the moment. I'll briefly explain this, okay? If the problem asks to find the domain and range, okay, so let's say you have a square, let's say you have this. You have, you have y equals x over 2, okay? This is your function and that's what it looks like. Okay? Your domain, you should know what the domain of this is already. It's all real numbers, okay? Okay, so how you find the range is you can, this is how I find it. I find this way easier. Okay, so you find the inverse of this. So you square it. So you have inverse, sorry. Okay. So you change the x and the y. Okay, and just remember you have to add the plus and minuses to a root. Okay, so now your function would look like this. Okay, so now your domain in this one is x is greater than or equal to 0, okay? So, now, going back to this one, your range is the domain of this problem, okay? So your range for this problem, y equals x squared, your range is x is greater than or equal to 0, okay? And your range for this one is actually your domain for the top one. So your range for this one is all real numbers, okay? So what I'm just getting to is domain and ranges for inverse so your domain and range for this, for your, your regular problem, is switched for your inverse. That's just what I'm getting at, okay? Hopefully that makes sense. I will now stop the video. I might do a little bit of 1.6, just to start it at the least. So that will next will be over 1.6.